Big windows. When you live on the moon, this is important. The only time you get to go outside, you're in the cab of a rover or you're wearing a spacesuit, which doesn't allow you to hear anything around you other than the sound of your own breathing and stuff on a radio. You can't smell anything except for yourself, and you can't touch anything except for through very thick gloves. So your best chance to feel a connection with the outdoors, such as it is through windows like this. And the longer you live in space, I bet you the more important that is. So why are these windows like this? Well, the red lattice work is reinforcing the strength of the glass so that it can hold in the pressure of the atmosphere, which is quite a lot of force, actually. But that configuration is quite strong, and the glass is made thick enough to handle it. It would be fused quartz, something that is an early priority to make the settlement capable of manufacturing in bulk. Sorry if I'm going a bit fast here, but you see that's offset a fair bit from the windows, and I haven't put it in, or at least it's not visible, but there would be another layer of glass on the outside of that lattice work. That's a safety thing in the extremely unlikely event that the glass is struck by a tiny meteorite. The outer glass takes the hit and the meteorite vaporizes, and then once it gets past that, it's too diffuse. The force is too diffuse to do significant damage to the inside glass. And as you can see here, there's a lot of dirt piled up on top of that overhang. So that overhang is blocking all of the cosmic radiation that comes from the sky, except along that fringe that you can see directly through the glass. Cosmic radiation is particles, usually protons, sometimes the nuclei of atoms, traveling at a significant percentage of the speed of light. So when something like that passes through a solid object, it basically is invisible to it. It isn't affected by it until it hits something. And because matter is mostly empty space, the odds of a particle hitting another particle only become great after it's passed through. Oops. Something like, half a meter to a meter of material. Once it does, it shatters whatever it hits, and then you have a cascade of particles, and that's when most physical damage happens. And if that happens inside your body, the results might be serious. We don't know how much you can tolerate events like that before something like cancer is likely, serious brain damage is likely. It's very mysterious because these are very high energy events, and you can't test this really in low Earth orbit on the International Space Station. I mean, it's not the same because the magnetic field of the Earth is changing the composition of those cosmic rays. It protects you to a certain degree. And it also, I mean, we've had somebody there for a year, but that's not the same as living someplace for decades. So we're going to have to figure this out once we have a community in a place like the moon. That's probably what's going to happen. When that happens, we'll find out what really happens to people in that situation. Okay, enough science. Why is there this giant swimming pool here? Okay. Another good way to protect somebody from radiation, both solar and cosmic, is to have a lot of water between you and the radiation. So while you enjoy watching your friends swimming around up here, you are completely protected from all the radiation coming from outside. And although we have this rather amateurish texture on the water, you would actually be able to see through this perfectly and sit there and munch on snacks and contemplate the universe and look outside all you want. No problem. So although a giant glass pool might seem pretty ostentatious, it's serving a real purpose, protecting a large part of the volume of this habitat from radiation. And a glass pool in 1/6 gravity is not that hard to pull off. We can talk about how difficult it is in another video when we talk about the pool, but anyhow, what that leaves in terms of the radiation dose is the dose that you're getting when you look out at the sky itself. So, because from most directions you aren't getting any radiation at all, just that part of your view where you can see the sky, that dose is probably okay. Best guess, probably fine.